Hi, my name's Wing Commander Michael Gann from Air Force Plan Jericho. I'm in the Australian War Memorial, and I can't think of a better place to talk about the interaction of ethics and technology than where we are right now, which is under the V1 flying bomb from World War II. Robotic and autonomous systems are systems that can do part of their job or all their job without human intervention, and artificial intelligence is a really huge field about machines that can think a little bit like humans. So two really large fields, and we've seen a lot of those come out in the last couple of years. Actually, here behind us at the V1 is one of the very first applications of those robotic autonomous systems in the military, which was used to send weapons across from Germany to England without risking the life of German pilots. So it was one of very early applications to reduce the cost of war in that way, but it also had a whole heap of other issues that came out in the way of ethics, because the weapons were not guided, they were imprecise, they were indiscriminate, and had a lot of ethical issues that we would have to deal with today. So robotic and autonomous systems have a great deal of utility. They can reduce the casualties, they can reduce risk. They can be operated in areas that may be radioactive or unsafe for personnel. They can also use their capabilities to go through large amounts of data and be effective or respond very quickly to rapidly emerging threats. However, because a lot of this is using some sort of autonomous reasoning to make decisions, we have to make sure that we have a connection with the decisions that are being made, whether it's in the building phase, whether it's in the training phase, whether it's in the data which underpins the artificial intelligence and the robotic autonomous systems. So we have an obligation, whether we're designing, whether we're setting the rules, or whether we're operating robotic and autonomous systems, to be fully aware of their limitations and their uses and how we're going to use them, but also the task that we're going to give them and the environment which they'll be used in. So definitely the task and context are critical for us to understand in bringing in these new technologies, which have a great deal of potential.
Hi, I'm Major General Mick Ryan. I'm the Commander of the Australian Defence College. I'm also a General in the Australian Army. How do we use artificial intelligence to supplement some human cognitive functions so that we can make better decisions, potentially more quickly, but not always more quickly. Sometimes we won't want to make them more slowly. But how do we make better decisions that are more connected across a more integrated organisation, and then test those decisions before we implement them? You know, I think this is a real area where we can make some advances, is how do we run war games more quickly with, you know, potentially tens of thousands of iterations very quickly to support senior leader and mid-level leader decision making? How do we use it to help us to prioritise things like logistics, medical support, and these kind of things? And potentially, how do we use it better to support what we build internally and what we buy from overseas, possibly? So that's the thinking piece, and there's any number of other functions we might be able to use it in training and education. And then the doing piece is, how do we use robotic systems to supplement human physical capacity? AI is about supplementing cognitive capacity, robotics are about supplementing physical capacity. Now, we've got a lot of experience in this, right? We've been supplementing human capacity ever since people developed wheels and tools to till the ground in the agricultural revolution thousands of years ago. So we know how to use tools, but when these tools have a level of cleverness, not intelligence, but a level of cleverness, that's a bit different. And we need to continue evolving our ideas and our concepts for using them, and how we prepare our people to work as a team member for these things, not just as a tool user for these things. And I think that is a mindset change that we have not yet progressed towards in our organisation. My first real exposure to some of these things was in Iraq in 2005, working with the Americans, and then Afghanistan in 2006, where we had an American detachment that had a Tiger Shark unmanned aerial vehicle. We worked very closely with them and used them for a lot of intelligence gathering and surveillance before missions, during missions, but also for deception as well. I didn't have the ethical dilemma of, you know, autonomous systems using lethal weapons, but, you know, sometimes you would make the decision to use it for deception rather than for the mission itself, and you had to decide what was the better course of action there. When I was brigade commander in the 1st Brigade, we had a few more of these systems, including having the infantry and engineers trial robotic systems for clearance activities. And my view is if you can put a robot between something that blows up and a human being, that's a really good thing.
So my name is Lauren Sanders and I am a Doctor of International Criminal Law. I've spent 20 years in the military as both a signals officer and a legal officer, and my area of expertise is largely operational law and the application of international humanitarian law to ADF operations. A great example of the use of autonomous systems in defence was the introduction and the development of the way that defence used UAS in an ISR capability in the targeting cycle. So a great example from recent operations would be the use of ISR to augment the targeting capability or the visual range of an Apache helicopter in operations in Iraq in 2017. Then MUM-T, but now HUM-T, so human-machine teaming, which was using the capability of the Reaper to effectively act as a forward location to visualise what the pilots were looking to target. Interestingly, because that system was one that was being used or tested in operations, the level of trust by command wasn't there yet to actually properly rely on that system to cut that visual feed to the pilot, to trust them to take the target as a consequence of what feeds they were getting from that UAS. What was actually happening instead is that those systems were being used to assist in target verification only after the targets had been verified through the traditional deliberate targeting process. So hopefully a mature version of that system will be using that HUM-T process to actually speed up and extend the range of those capabilities without having to come back to a command decision headquarters to actually go through that deliberate targeting process, but use it more as a dynamic targeting system.
Technology is never a silver bullet in any military institution. It really is about the ideas, the new organisations and the people who use these new technologies. So how do we team these things with people in a way that makes us more likely to be successful in our missions, from warfighting through to humanitarian assistance, disaster relief, and do it in a way that accords with the values of our country first and foremost, and then our institutional values as well. But that's kind of the framework I use when I think about these systems. I guess the thing that I think about now is we still don't have a lot of them. We might have a few thousand autonomous systems, but I can foresee a day where instead of having one autonomous system for 10 or 100 people in the ADF, we'll have a ratio that's the opposite, where we might have 100 or 1,000 for every person in the ADF. We don't have a training system. We do not have an organisation, and we certainly don't have an ethical framework at the moment that would cope with that kind of density of massed autonomous systems. And that doesn't include autonomous systems that might be able to make the decision to kill a human being. That kind of occupies my thinking. Is like, well, how are we leaning into the environment and what it might be in 10 years, and how do we enable our people to not just cope in this environment but maintain a level of decision making capacity and awareness of what's going on, so these systems don't get away from us.
Professor Jason Scholes, I'm the Chief Executive Officer for Trusted Autonomous Systems, which is a Defence Cooperative Research Centre. I think there's a huge capability advantage to come from RAS AI for the Australian Defence Force. We have a vision in our centre for what we term the smart, small and the many. This is a contrast to a platform's view of the past, which are complex, large and few, and often manned systems. Those manned systems we really can't get enough of, and we can't afford to get enough of. So we see this vision for smart, small and many to be a transformational one and a disruptive one. I think it will mean ways to develop and achieve what's termed mosaic warfare in the US, which is the ability to set up multiple simultaneous kill chain options. This can be a huge deterrent to an adversary and provide many more options in defence and offence. I think also a reflection, if you look at the conflict between Azerbaijan and Armenia late last year, is an idea of what the shape of things are like today using these disruptive technologies, much less the things that we're developing and are being developed. Technology, people and systems together can make for better decision making in a military context. And in order to do that, we should recognise some things, that people behave differently when they're accountable, and perhaps they know they're being watched. So people watch the technology during operational use, but it can work in another way as well, because not only might those robotic systems be watched, but the robotic systems can watch one another, and they can watch what people do. So an aberrant behaviour that might be due to a failure of a machine, for example, might be picked up by other machines and communicated, and it might signal an attack or a signal that something's gone wrong with an algorithm, or so on. So we have potential to have a much more systemic perspective on accountability.
I'm Stephen Bornstein. I'm the CEO of Cyborg Dynamics Engineering, and I'm the Managing Director of Athena Artificial Intelligence, which is a spin-out AI company initially created through the Justified Autonomous UAS project within the TASD CRC. So the ADF's quite a small force in terms of its numbers, but within Australia we have a lot of technology, and particularly with Australian industry content, we're now seeing the ability that we can produce these small semi-disposable or attritable systems at a low cost that can achieve high payoff based on the level of autonomy, AI, and how we actually network to achieve a combined effect with a small number of operators commanding them.
When I was in East Timor in 2000, I was serving with the 6 RAR Battalion Group, and I had the engineers, and we were in charge of keeping the roads open, especially during the wet season. And one particular day, the road was closed between Ballabo and Maliana on a hillside, and there were landslides, and I had to make a judgment about whether it was safe to send our sappers out to clear the hillside, clear where it had gone over the road so we could reopen the roads. And that was potentially putting them in significant harm. It wasn't about being shot by someone, it was about, could another landslide see, sappers and their equipment being, washed down a hillside and hurt or killed. That was a real dilemma. Now, we ended up going ahead, but it took us a lot of research and a lot of work beforehand and risk assessment with myself and other people to move ahead. And that's just one of the kind of ethical dilemmas you have, not just during everyday life, but on operations as well. First thing I do is, who else has faced these kind of dilemmas previously? How have they dealt with them? And then I think about, what's the purpose of doing or not doing certain actions. And then I think about primarily the people, not just their physical welfare, but also their moral welfare, and what might be the impact on them of doing something that either won't accord with our values or won't meet the mission in a way that we should, or might just have a short-term outcome that will compromise longer-term strategic objectives. But most importantly, I think, is you need to think about the moral welfare of those who are involved. I am by nature someone who likes to move forward, which can make me impatient, but it can also sometimes mean you don't take all the advice you need to take, so you do need to check yourself in making sure you are exposing yourself to a diverse range of views. Sometimes you don't have time to seek the full range of views or opinions that you might need. Sometimes you just need to make a decision. Every situation's different, but you get better at it the more decisions you make. And really good decision making is about making as many decisions as you can and learning about what works for you in both analytical and kind of hasty decision making over many years and indeed decades. Well, firstly, you've got to understand your own country that you're serving. You can't make ethical decisions without having a contextual understanding of the values of your country, what it stands for, what it believes in, and what it'll fight for. So that's the first and probably the most important thing. Secondly, you've got to understand the values of your institution, and the ADF over the last couple of years has gone through and developed and implemented a new set of institutional values, which have been very important, I think. And then you've got to ensure people understand what those values are, and then train constantly and drill people in what is the ethical way of staying with those values in what are pretty austere, ambiguous circumstances and operations. You can't just give people a lesson on these are our values. You need to drill people on the different kinds of rules of opening fire, the rules of engagement, those kind of things. It needs to almost be a muscle memory, not something that's academic and may be useful. This has to be something that's integral into how people think and how they behave. And it's not just leaders, it's everyone. In the laws of armed conflict and rules of engagement, we run people through drills before they go on operations to try and build that muscle memory of good ethical decision making when they go on operations. So I think, in the thinking piece, you can use artificial intelligence and clever algorithms and simulations to expose people to lots and lots of different scenarios. It doesn't provide a template for them, it doesn't prepare them for everything, but it gives them a mental model of how they might think about these things when circumstances turn bad. And once again, the physical stuff. We need to prepare people to team with robotic systems, almost from the day they join the military, not from when they go to a unit, but these things need to be teamed with people right from the start. There's no point arguing whether that's, how many of these things are going to be, or if they're going to be. They are going to be part of the environment. They're going to be part of society, and we're going to see more robotic systems doing more things. We need to team our people early, and we need them to understand that they're going to be an ever-present part of their life in a military institution.
Certainly, character ethic is reflected very strongly in defence values, which are part of our ethical viewpoint. Those include service and placing others above self, courage, strength of character, to say and do the right things, respect, which includes humanity of character and the valuing of others, integrity, inconsistency of actions in character to align thoughts, actions and words in doing what's right, and excellence, which is that willingness of character to strive to be the best you can be. And to live the values, I also note Defence has a set of behaviours about acting with purpose for defence and the nation, being adaptable, innovative and agile, be collaborative and team-focused, and to be accountable and trustworthy, to reflect, learn and improve, and to be inclusive and value others. All of these values and behaviours are included whether we're a robotic and autonomous systems augmented force or not. Now, ethical decision makers are human, but they're also machine decision makers and machine decision aids. We embed human conceptualisation in the machines, so they are our representatives in battle, in effect. By this, I'm not meaning that machines may have moral autonomy, or will not yet, at least anyway. Yet if machine learning means we train machines, are we not imparting our values through that process? So perhaps then machines might comply in some sense with defence values in a rather unique way. This may be a little dangerous, but some food for thought. Perhaps those values of service for a machine can mean machines operating as tasked under mission command. Maybe courage would mean machines operating within the ADF system of control as put forward by the Chief of Defence Force. And that includes the courage to intervene if the machine believes, if you like, a human has made an error. For example, a weapon to prosecute a target has been identified locally by the weapon system to be a red cross through machine learning, and might defer that action or respond back to the operator requesting the operator to override it or override it prior to the action if necessary. Respect was another one of those values. Machines accept human guidance and they'll log it for the record. Integrity, with machines processing, reporting and acting consistently within commission command constraints. And excellence, machines optimising to be the best they can be in support of human command. So not only, I guess, is there a question about what it is that makes an ethical decision maker, but who it is that makes them. So what are the principles involved in the research, design, development and use are also relevant to that question. How will you deal with, in the future, the potential for the machine to say no to you, that the machine may object on legal or ethical grounds for an action that you're requesting?
Humans must own the decision-making process. They can augment their cognitive and physical functions. I don't see a problem with that. But when machines start making decisions about human life, there's a real issue there. And I know that there's all kinds of research that says, machines often make better decisions, autonomous cars have less accidents than humans, and autonomous aircraft have less accidents than humans. And I understand that, I'm not disputing any of that research, but the military is the only element of society that can lawfully take a human life as its first option. And human beings in a military institution are subject to an unlimited liability. That imposes a profound responsibility on commanders to make good decisions about taking the lives of others or risking the lives of their own people. We cannot hand that over to an algorithm. They do not understand the context of why human life is important. They do not understand the context of why protecting it instead of destroying it is always our first option.
There are a lot of concerns by the public and defence people alike that our ethical standards may be quite different to our potential adversaries. And this kind of ethical asymmetry, in a sense, may create concerns that we are ethically conservative and put our defence force at a disadvantage. I don't think we should lose the ADF's advantage if we get the systems right and the processes and policies. For example, in Autonomous Warrior 18, we developed and demonstrated a policy-based control system for robotic autonomous systems and AI. This allowed a management of time, space, spectrum, but might also manage targeting related processes by changing in effect rules of engagement and through electronic policy, which can be implemented throughout the entire network or internet of robotic autonomous systems things.
I'm Kate Devitt, the Chief Scientist of Trusted Autonomous Systems Defence Cooperative Research Centre. In 2019, Plan Jericho Air Force wanted to investigate the possibility of AI ethics principles for the Australian Defence Force. And they worked with Defence Science and Technology Group and the Trusted Autonomous Systems Defence Cooperative Research Centre to have a workshop to figure it out. At that workshop, over 100 people from 45 organisations thought about what would be good AI ethics principles to have in an Australian context supporting Australian values, with evidence from experts across many different subject area domains, from military ethics, human factors, engineering, artificial intelligence, military context, legal scholars. So we brought them all together to find out what we might want to do in an Australian context. And from that workshop came a Method for Ethical AI in Defence DSTG report that now provides the first step of a best practice framework for ethical AI development, testing and use in the Australian Defence Force and Australian Defence more broadly. That framework recommends 5 facets of AI: responsibility, governance, trust, law, and traceability. These facets encourage us to ask questions rather than provide specific answers. So under responsibility, who is responsible for the AI that you're developing or going to deploy? Is it a commander? Is it an operator? What is the system of control and the system of responsibility, and how is that responsibility and accountability managed inside Defence? Governance covers a huge range of mechanisms that might enable and constrain the use of robotics, autonomous systems and artificial intelligence in Australian Defence. Governance can cover laws, it can cover culture, it can cover operational guidelines or safety manuals. So there are many systems of governance that can be worked in together and in interlocking ways to ensure safe and effective use of these systems in Defence. Trust is a really interesting aspect of the facets of ethical AI for Defence. Trust is multifaceted. It is certainly about competence. You want to trust something that's reliable, that's got enough experience, enough skills in order to get the job done in a way you anticipate it to be done, appropriate for the context of its deployment. But it's not just about competence. So for example, you might trust Google Maps to get you from A to B because you know it's a really reliable system. But you might also be a bit worried and say, well, what is Google doing with my data? Am I agreeing to the use of my location by Google in some future way of interacting in the world? You might ask that question. And in that case, you're not questioning the reliability of Google, but you might be questioning its integrity. So integrity is the other aspect of trust that's worth focusing on. So we don't just want competent systems, we want those that have a high integrity level. Well, what is integrity? Well, for a human, it's probably got to do with character, motivation, and honesty. And how to transplant that into a machine is an interesting question, and maybe there is some asymmetry there. But certainly we can make machines honest in the sense that they can be suitably transparent within security considerations with humans, so that humans can understand what they're doing, and that humans can explain and justify how they're integrating with those systems and machines. You can certainly have good integrity in the design parameters of robotics, autonomous systems and artificial intelligences, and you can test for the use of those systems with humans and with human decision making in evaluation contexts in order to make sure that the integrity of those systems is maintained when they're deployed. Law, it's a big topic. We've included it in the Method for Ethical AI for Defence framework because abidance with international legal obligations is a key part of what Australia commits to. So Australia follows international humanitarian law, and all new means and methods of warfare need to go through Article 36 reviews. And so we have included law as a key part of what it is to be ethical using robotics, autonomous systems and artificial intelligence. Traceability is the fifth and final facet of ethical AI for defence. Traceability means that the decisions that are made by these systems are traceable to humans in post-event reviews and in the analysis of how we're making decisions, what went into those decisions, who was there, when did they occur, and what were the consequences of those decisions. This enables us to grow and learn, both in simulation and in the unfortunate case of a deployment in a conflict, enables us to consider how they're used and to improve the way these systems are used into the future.